Okay, alright. So dalam komponen komputer kita, okay, kita based on volume architecture, kita ada CPU, betul? Okay, we have a CPU, you have a CPU, you have the input outputs, okay, and then you have a main memory. So dalam CPU kita ada beberapa jenis register, which is later on will be explained to you. Okay, which is a program counter, kita ada IR, instruction register, kita ada memory address register, kita ada memory buffer register ataupun memory data register, and then kita ada input output punya address register and also input output for buffer register. So in order to connect from this CPU to main memory and also the input output module, kita ada satu we call a system bus. System bus ni pun nanti kita akan belajar later on. Alright, so they have a system interconnection. So the system interconnection ni kita panggil dia sebagai system bus lah. Okay, how you connect from this component to another this CPU to memory, from memory to the input outputs, okay, and so on. Okay. Alright, so kita tengok computer component in the top level. Okay, in the top level, what are the main things that are important inside the computer component? One of them is the CPU, okay, Central Processing Unit, or known as a processor. Okay, kalau you cakap CPU, processor adalah benda yang sama lah. And then we have a memory. Okay, memory ni pun dia ada dua jenis. Nanti kita akan tengok later on in the next chapter. Okay, kita ada memory, kita ada primary memory and also secondary memory. And then we have input output devices and also system interconnection. So every devices, okay, have their punya system bus. They are connecting, okay, among them, okay, through the system bus. Okay, so the setiap ni dia ada dia punya address lah. Okay, dia ada control register, address register and also data register. Okay, so maknanya kalau dia perlukan hantar data daripada CPU kepada memory, so they use data line lah. If they want to send the address, okay, CPU nak ambil program ataupun data in which address dari dalam memory, so dia kena melalui address line. And then kalau control signal, so contohnya dia nak terminate of the application, so dia hantar control lah, okay, dekat memory so that they can terminate the control line. Sama juga dengan input and output devices dan juga ada komponen. Okay, alright. Kalau kita tengok kat sini, you akan tengok kat sini, kita have a motherboard kan? Okay, so this is a motherboard. Okay, ni motherboard biasanya komputer. Okay, dalam desktop. Okay, so you boleh buka komputer you. Okay, you boleh tengok dekat komputer awak. So this is a motherboard. We call a motherboard. Siapa tak pernah tengok motherboard? Ni lah dia motherboard. Okay, so dekat dalam motherboard ni ada beberapa komponen. We have a chip, we have integrated circuits. Okay, they are being integrated masuk ke dalam ni. Okay. Alright, so the komponen-komponen yang penting, okay, dalam kita punya komputer adalah another things is central processing unit. So this is your punya processor. Okay, so processor you ada cooling pad, okay, kita ada cooling fans, okay, dekat atas dia, okay, alright. And then dalam CPU kita ada control unit, kita ada arithmetic logic unit, and then kita ada some internal register. So next, kita ada input output devices. So input output devices, saya tak payah cerita. So you memang dah tahu. Okay, input and output ni, they have a data instruction. They need to get into the system or give a results. Okay, you convey dia punya or display you punya results lah. Okay, and then you have a main memory. Memory pun dia akan berada dalam input output. Dia dalam you punya motherboard. Okay, so normally this memory have a temporary storage code and where the result is being needed. Okay, alright, so this is explanation. Okay, the main structure dia. Okay, what is the CPUs? Okay, what the memory does? Okay, what the input outputs and what the system interconnection lah. So the explanation about the component tadi lah. Okay, so the structure of the CPU. So kita tengok zoom in, okay, satu persatu. So the first component adalah CPU. So inside the CPU kita ada arithmetic logic unit. Okay, kita ada arithmetic and logic unit. Okay, kalau dia perlu buat arithmetic, dia buat arithmetic. Kalau dia perlu buat logic, contohnya you buat one true or false. Okay, you nak buat conditions. Okay, so dia perlukan logic. So bila dia guna logic, then dia kena pakai logic operations lah. Okay, and then register ni kita akan ada beberapa jenis register dan you akan kena yang akan tahu. And then you have a control unit. So the control unit ni, okay, is responsible to interconnect, okay, between the among components inside the CPU. Okay, so they have internal person. Okay, so now kita tengok the CPU processing unit. Okay, central processing unit. Okay, so processing unit actually the integrated circuit. Okay, they call integrated circuit are known as a processor, and which is being located in the motherboard. So they are located in the motherboard. So CPU ni is just like a brain, okay, like a brain of the computer. Okay, without this processor, your computer will not be functions. Okay, alright. So what are the functions of the CPU is to execute and store in your memory by fetching the instructions, to decode and translate by translating your program instruction into the computer commands, okay, and which can be processed, okay, and then they can execute one of another and store back into the main memory. So they have a functions, okay. Central processing unit ni is just like a brain, dia akan process, okay, dia akan bagi tahu, okay, ini the input devices, so dia akan through your program lah, through your instruction. So the brain will be tell what the input devices need to do. Okay, alright, they need input data. So they input data. Okay, so they hantar maklumat and control signal to the to the input devices that you are required the input data. Okay, alright, kalau you perlu print, okay, so the processor akan execute this kind of instruction of print ataupun you kata send out. Okay, so bila send out, you display your print information, you display your results, okay, through your monitor to your key LCDs. Okay, so all these things they akan tell the CPU, okay, the processor akan bagi tahu they require output, and this output will display at your punya monitor. Okay, so dia semua nampak lah. So itu melalui arahan. Okay, so that's why you need learn programming. Okay, dalam CPU we have three major components. We have a control unit, arithmetic logic unit dan juga register. Alright, so this is a microprocessor. So microprocessor are the same of central processing unit? Yes. Okay, currently kita punya processor is more tiny. Okay, the module is more tiny. Kalau kita tengok physical dia secara tiny, but we require high processor. Okay, alright. So kalau kamu tengok sini dia ada expansion slot. Okay, kita ada memory module. Okay, and then kita ada processor, and all these things is called a motherboard. Okay. Alright, so kita tengok on the control unit. Dalam CPU kita ada control unit. So this control unit have a control of the operations of the CPU and hence the computer. So dia juga berfungsi untuk control all the signals that may happens inside during the operations of the CPU. So dia yang akan control. Okay, so what are arithmetic and logic unit? Arithmetic and logic unit is used to perform you punya computer data processing. Contoh calculation, logic operation, comparison, and so on. Okay, so any operations that involve in the CPU will be performed in the arithmetic and logic unit. And how about the register? So register, they provide the internal storage, okay, to the CPU that required used to hold your data while the process or the execution process is occurred. Okay, so bila dia nak buat tambah, okay, so they need the register to hold your data, okay, for the additions punya process. Okay. Alright, now we have a CPU interconnection. So CPU interconnections is a mechanism that used to provide the communications among the component inside the CPU itself. Okay, so kalau register dia nak connect, dia nak hantar, so the register they need to send a control signal to the control unit. So dia kena hantar lah, okay, melalui CPU interconnections. Okay. Alright, so this is how you look into the CPU. Kita dah zoom dah. Kita tengok dalam CPU, kita ada ALU, kita ada control unit, and then dia ada dia punya internal CPU internal bus. So dia ada dia punya internal bus. Okay, and then you have a register here. So we have several types of register. Okay, kita ada APC, program counter, okay, instruction register, lepas tu dia ada accumulator register, you ada data register, you ada memory, okay, memory address register. So kalau memory address register means that they are connecting to your memory and dia akan hantar only a address line. Okay, so dia responsible untuk hantar address saja. Okay, address apa? Address instruction awak, address kat mana your punya data ataupun instructions will be reside in your memory. Okay. Alright, and then bila dia operates, okay, they require some ALU, so they require arithmetic, so they go to the ALU through your CPU internal bus, and then they akan operate all your arithmetic, okay, or logic operations. Okay, so how your control signals? The control signal will control among the registry, among the ALU, among the other and another components, okay, between the CPU. Okay, so tadi kita tengok dalam CPU ada apa? Okay, control unit dan juga ALU. So now kita tengok on the register. So register is is singles, okay? Is actually dalam CPU dia actually is not it's a permanent storage, tapi current storage, okay, within the CPU used for the particular and they will be defined the purpose. Setiap register ni ada dia punya purpose dia. Dan some of the register are general purpose. So maknanya you boleh guna untuk any purpose for any activities, okay, that involve inside the CPU. But each of the register also have their own purpose, okay. So they hold the binary value temporary for storage and manipulate, and also they can use for simple calculation. Okay, so the manipulated directly by the control unit during executions of the instruction. So you have three types of register here. You have a data register, you have the address register, and you have a status register. Okay, so mostly inside the computer you have a general purpose register, or we call it accumulator. So this accumulator actually a type of register, okay, whereby they can be considered to be in a part of the ALU. Okay, so contohnya kalau dia nak perlu tambah, so dia perlukan ambil data daripada memori masuk dalam accumulator, dan daripada accumulator dia akan diproses di dalam ALU. So during that time, who are responsible to hold your data is accumulator. Okay, so apa konsep register ni? They are very small, okay. So they are not the permanent storage, but dia permanent, physically permanent, okay. But the sifat dia bukanlah sifat permanent, okay. So they are manipulated directly by the control unit. So here is easily manipulated from the control unit, and the wired each wire of register have the wired functions, okay, and they have a size of each of register. So normally dalam register ni dia ada sama ada dalam 16 bit ataupun 8 bit ataupun 32 bit ataupun 64 bits. Okay. Alright, so the whole data and address also instructions. Okay, dia berfungsi untuk hold your data, not only a data, the address and also the instructions, okay, when the process execution of your program or your punya system. Okay, so where is the use of register? So the use of register, if you have a scratch pad for currently executing the program, they hold the needed quickly or it can be frequently. So they boleh hold, okay, data and they store information about the status of CPU and currently executing program. So they boleh bagi tahu status. What are the current status of your CPU, okay, during the executions of your program. And also they have a address for the next program that can be instruction through your punya program counter. So the signals come from the external devices lah. Kalau you have external cucuk, you cucuk pen drive ke, you cucuk external hard disk ke, so dia akan bagi prompt pada processor that have a new hardware is being connected to your computer. So this is the register that involved, okay, dalam processor. Okay, you have instruction register, normally they hold your instructions. Kalau program counter, they contain the address of instruction that currently dia akan execute. Okay, general purpose register ni dia ada banyak. Okay, there are a lot of general purpose registers which can be used, okay, during your writing the codes, okay, writing your machine codes nanti. Okay, so you have a different general purpose register, and mostly they have their own purpose lah. Okay, and then memory address register. So they hold the address of the locations to or from which data can be transferred. So they have a component, okay, inside your selain daripada basic general purpose register, kita ada juga memory address register di mana this register is used to hold your address, okay, ketika of the locations, okay, where which data need to be transferred. And then memory data register is always contain your data lah, of course, Okay, whether we need to be read ataupun whether we to be out of the address location. Okay, so ni dalam processor. So dalam processor kita ada control unit, ada ALU, okay, you ada MAR, MDR, okay, personal counter and also IR. Okay, so this is the functions of the register. Okay, so PC is a program counter, IR is instruction register, ACC is accumulator, memory address register and also memory buffer register ataupun we call a memory data register. So setiap register ni, okay, terutama sekali MBR dan juga MAR, okay, they have the specific system bus. Okay, they have a specific system bus because they use a different register. So for example, memory data register, they require some data lines, okay, between the register and also the memory, okay. And then we have a MAR, okay, yang tadi MAR, okay. And then we have a MAR, so MAR, okay, for address line lah. So kalau dia perlu ambil data daripada a certain address, so the MAR will be saved as the address line. And then kalau dia turun, okay, dia turun, so they also use a MAR. Okay. Okay, so apa ada dalam control unit? So dalam control unit kita ada sequencing logging. Okay, kita ada control unit register and decoders and also we have a control of memory. Okay, so dalam control unit, apa yang ada dalam control unit? Normally they interprets and control the execution of your instructions. So all the instructions yang dalam high level language tu, dalam programming ke, Python ke, okay, or whatever it is, dia akan change into a machine language and the responsible to do that is your processor. Okay, through your control unit. So your control unit berfungsi untuk interpret the controls. Okay, interpret the control. Apa yang diperlukan oleh program tersebut. So the issue of the signal necessary to control the operations of the microprocessor. Okay, bila kita ada issue a signal ni, so the CPU will be alert. Okay, so there will be alert. Okay, there will be have some new process coming ataupun there will be alert lah. Okay, kalau ada instructions lain yang sedang tunggu untuk you untuk komputer is being used. Okay, so responsibles. Okay. So the result of the sequencing of the actions, okay, where it control that register and devices are to be enabled and when they are to be functions, okay. So the control is achieved through the structure we call a control bus ataupun we call a control signal, okay, a read carry control signal. So selain daripada control unit kita ada bus, okay, bus nama pun bus. So bus what they do, they carry the kalau bus mesti bus tu kita tahu dia bus, dia carry the okay, dia carry the people kan. Okay, kalau bas sekolah dia carry budak sekolah. Okay, kalau dia bawa orang bawa kilang, so dia bawa orang kilang, so maknanya bas kilang lah. Okay, okay. Sama juga dengan control bus dalam komputer. So your bus ni is actually a parallel electrical line ataupun dia panggil sebagai path. Okay, that connecting a source to the destination. Okay, they connect. Okay, so your system bus from PC to memory, from memory to the input-output devices. Okay, so they're connecting from the source to destination. Okay, so they have a common path that use a specific exchange of between the various block functions. So they masing-masing they have specific exchange. Okay, specific use okay of the data. Okay, and then we can be printed the circuit board or the parallel connected wire into a ribbon, which is capable of conductive parts, okay, that adds to the microprocessor chips. Okay, so this ada juga yang printed circuit board that use a parallel connecting wire, di mana yang ini normally untuk microprocessor. Okay, other than that, okay, we have a memory management unit. Okay, memory management unit is supervise fetching instruction and data. So input-output interface kita sometimes will combine with the memory management as a unit, a bus interface unit. And then we have an instruction decoder. Okay. Alright, so dalam arithmetic logic unit, okay, kita dah tahu dalam komponen selain daripada control unit, kita juga ada arithmetic logic unit. So dalam arithmetic logic unit ni, okay, they normally used to perform arithmetic and also logic. So bila kita cakap arithmetic, of course they do some additions, they do some subtraction, they do some multiplication or divisions and so on. Okay, and do some comparison kan. Okay, untuk arithmetic. Okay, tapi kalau untuk logic, they use for the logic punya function lah. Okay, so in the short ALU perform, okay, they perform operations in addition, subtraction, and so on, and also the logic operations such as like AND or exclusive or. Okay, alright, so that are logic operations. And what are the component inside the ALU? Kita ada comparator. Okay, so normally is our ALU ni dia banyak functions lah. Okay, cumanya dalam semester ni awak tak nampak secara direct, okay, bagaimana ALU tu works lah. Okay, we have a comparator, kita ada logic register, and also kita ada shifter. Okay, so ada shifter, ada logic, okay, ada comparator, kita ada rotator, okay, rotations, okay, they do some rotations, okay, to escalating your data, okay, and then the operations of value is controlled by the control signal to facilitate the sequencing and also the operations for each individual block. Okay, the operation of value ni controlled by the signal. Okay, signal kata tambah, so dia buat tambah. Kalau signal tu kata tolak, dia buat tolak. Kalau signal tu kata darab, dia buat darab lah. Okay. Alright, the most important thing about the processor is about the processor machine cycle. Ini pun ditekankan dalam you punya programming, betul tak? Okay, so process machine cycle inilah you belajar daripada semester pertama sampai dah semester akhir dalam degree awak. Okay, kita zoom in sahaja benda, okay, yang part of dalam computer system. Okay, so processor machine cycles, dia ada 4 main, ini memang kena hafal, ini kena master dan ini kena tahu. Okay, the 4 operations is first, okay, of processor, dia kena buat apa? Dia kena fetch. Dia fetch apa? Dia fetch you punya data, dia fetch you punya program, dia fetch you punya instruction. Ke mana? Ke dalam memory. Okay, itu kerja pertama processor. The second one, selepas dia dah fetch you punya data, you punya program and so on, now they need to decode. Okay, dia kena decode you punya instruction tu kepada into a command, into a machine codes. Okay, so whatever instruction you do dalam Java ke, dalam Python ke, dalam Ruby ke, apa semua tu, semua instruction tu dia akan translate to the machine code. Okay, kalau macam you ada compiler, you pakai compiler lah. Kalau you ada assembler, you pakai assembler lah. Okay, so dia akan translate your instruction into the command. So normally is done by the control units. Okay, lepas dia dah decode, okay, instruction awak ataupun program awak ataupun dah punya data tadi, dia akan execute. So they execute, they carry out the commands. Okay, so when you execute the commands, dia carry out. Kalau dia perlukan arithmetic operations, so dia buat arithmetic operation. Kalau dia perlukan logic operation, so dia akan pergi dekat ALU untuk buat the logic operations. So dia ada control lah, of course. Okay, control beritahu. Okay, dia nak buat arithmetic, dia nak buat tambah, so dia buat tambah. Kalau dia nak buat tolak, dia buat tolak. Kalau dia nak buat logik, dia buat logik. Okay, alright. And then all your results, okay, tadi dia akan guna the fourth one, which is store you punya result, all your information into the memory. This is a process, very fast cycle, okay, by CPU. Okay, one complete machine cycle, dia akan buat four phases ni lah. 4 phase of machine cycle. Okay, so for example, you execute you punya instruction lah. Okay, you buat satu very simple instructions, okay, coding awak. So bila dia code awak tu, okay, so dulu sebelum tu awak akan fetch dulu. Okay, dia akan fetch masuk dalam memory. Okay, kat situ kalau declare variable awak and so on. Okay, so bila dia ni, dia akan decode dulu. So bila dia decode, okay, dia translate dulu. Okay, they translate your instruction to into a command, okay, which is understand by the computer. Okay, that's why you need a compiler kat situ. Kalau dia high level language, we need a compiler. Sebab compiler yang faham the syntax on instruction yang you nak before you execute. Okay, and then bila dah decode, then you tekan execute. Okay, bila execute, you tekan run, betul tak? Kalau dalam compiler. Okay, so bila you tekan run means your instruction tadi, lepas dia dah decode, actually dia dah execute. So bila dia dah execute, okay, dia tengok lah. Bila dia execute, tengok lah instruction. Kalau you dalam instruction you ada in, so maka dia perlukan instruction, perlukan input devices. Kalau dia perlukan, you kata out, so dia perlukan display. You perlukan output devices. So dia perlukan output devices lah. Okay, to display your results. Okay, alright. So they will be stored. Information tu kena simpan lah. Okay, dia akan simpan dalam memori. Okay, dalam instruction cycle, kita akan tengok, okay, dia ada two main phases. One is a fetch cycle and one is execute cycle. Okay, so dalam fetch cycle, okay, dia akan fetch your punya instruction to the next instructions. Okay, alright, so the next instructions. Okay, so and then they start execute the instructions. Okay, so they fetch the instruction. Okay, they fetch the first instruction and then the program counter akan go to the next instruction. They need to be the fetch. And then the instruction yang sebelum ni dia dah fetch, okay, dia akan pergi masuk ke dalam execution punya cycle. Okay, dia dah decode semua bahagian. Okay, dia akan masuk ke execution punya cycle. So, apa yang the program counter akan pergi ambil lagi lah instruction yang lain. Okay, untuk dia ambil, untuk dia proses. Okay. Alright, dalam fetch punya phases, dalam fasa fetch, apa yang dia perlu buat? The program counter akan hold you punya address of the next instruction to be fetched. And then what the processor do? Bila dia fetch the instruction from the memory location and pointed by the program counter. So program counter first thing dia akan pegang apa? Of course program counter dia akan pegang address. Okay, dia pegang address that need to be executed by the CPU. Instruction address di mana instruction yang the next instruction yang dia kena ambil daripada memori. So, bila processor fetch instruction awak tu daripada memori, okay, yang dia pointed daripada program counter tadi, okay, the program counter sendiri akan incremented by 1, okay, in order for them to fetch another instruction, okay. Alright, so instruction yang loaded daripada tu dia akan masuk ke dalam IR. Okay, so tadi address. Okay, bila berkata address ni, the CPU akan pergi dekat memory, look at the address and then dia akan ambil instruction. So instruction yang dia ambil daripada memory tu, dia akan masukkan ke dalam instruction register. Okay, dia perlukan instruction register. So, bila dia dah masuk instruction register, dia processor akan interpret dia punya instruction tadi ataupun kita dah masuk dalam decode phase lah. Okay, in order to perform apa yang dia perlukan. Okay. Alright. Untuk execution punya phase, okay, processor dia dah decode instruction awak and then dia akan set up what are the circuit that involved in order to perform you punya operation lah. Okay, contohnya you perlukan arithmetic. So, nanti dia akan pergi ke arithmetic punya function lah. Kalau dia perlukan data, okay, dia perlukan logic, dia akan buat logic lah. So, the actual execution operation, dia ada processor to memory. Ini normally used for your data or instruction that transfer between the CPU and memory. Okay, antara processor dan juga input output device awak. Okay, ketika dia nak decode tu, dia nak execute tu, tiba-tiba you nakkan input devices. So, bila input devices, you perlukan data ataupun input daripada devices. So, dia perlu data transfer antara CPU dan juga input output module. Lepas tu, you have a data processing. So, data yang processing yang terlibat adalah untuk operate whether that program ataupun yang instruction tu melibatkan arithmetic ataupun logic operation lah. And then control, okay, control ni normally is used untuk contohnya looping, okay. You nak control berapa banyak loops, you nak ulang the instruction tu berapa banyak kali, okay, you nak susun data dalam bentuk array, okay, semua tu ada control. Okay, berapa kali dia nak kena go to the next instructions, okay, and then you can combination of both lah. Okay, the executions of the operations, it can be combined everything. Okay, sebab so that the application of your program can be functions lah. Okay, as what you require. Okay. Okay, so the very simple processor, okay, contohnya kita ada 16 bits, okay, for instruction of data. Okay, so the instructions, okay, we have the opcode plus the address. Okay, so the opcode normally is have a 4 bits. 4 bits represent the operation code. Okay, and the address will be in the 12 bits. Okay, kalau word size dia 16 bit. Kalau dia 32 bit, ada dia punya instruction dia, ada opcode and then address and baru dia data dia lah. Okay, so the operation codes, okay, they depends, okay, per the instruction. Contohnya, we have 1 Okay, mesti address. Dia go to accumulator. So daripada accumulator pula dia ambil address. So daripada address dia akan campur address tu dengan accumulator masuk dalam accumulator lain. Accumulator. Okay. So ini example Okay. So example of here. Okay, contoh saya explain kat sini. Okay. Right, imagine you punya component of computer, kita ada CPU, okay, kita ada memory. Okay, alright. So the first thing is dia tengok dekat program counter. Okay, program counter you tunjuk address 300. So apa computer you buat? Okay, computer you akan pergi ke memory dekat address 300 and dekat sini ada instruction. Okay, instruction ni dalam nombor lah. Mungkin dalam instruction, mungkin instruction ada address lah. Okay, it can be a numbers, it can be address, it can be a data and so on. Okay, so apa yang berlaku ialah bila dia pergi kat address 300, dia nampak ada 1940. So 1940 ni, instruction register ni, dia this kind of instruction ni, dia akan masuk ke dalam instruction register. Everything mesti start dengan instruction. Dia tak boleh data. Kalau tidak, dia nak buat apa dengan data tu kan? So dia start dengan instruction. First thing is you have to do the instruction. So dia pergi kat 300 ni, dia akan pergi nampak, okay, ada instruction of, ada 1940. So 1940 ni dia akan masuk ke dalam instruction register. Okay, so bila dia dah pergi kat instruction register, okay, so dalam 1940 ni, okay, 1940 ni, okay, dia bagi tahu, okay, dekat instruction ni dia ada opcode dengan address kan? Betul tak? Okay, the first code dia kata 1. Okay, 1 maksudnya dia load. Okay, contoh. Okay, so instruction register 1940 ni dia akan decode. So bila dia decode instruction tu, dalam tu ada opcode dan juga address. So opcode dia adalah yang first one lah. Okay, and 940 ni adalah dia punya address. So apa yang dia buat ialah dalam instruction 1 dia kata load data. Okay, so dalam instruction 1, katakanlah dia kata load data daripada address 940. So bila 940, so dia akan pergi ke address of 940 ini dan apa yang dia buat, data dalam 003 ni akan dihantar ke dalam accumulator. Dalam accumulator register lah. Salah satu types of general purpose register kan yang you boleh gunakan. Okay, now next they go to program counter awak. Tadi dah 300, dia naik jadi incremented by 1. So jadi 301. Okay, dalam 301, okay, dia kata apa? So they go to the memory balik. Okay, memory, okay, melalui memory address register lah. Okay, so program counter akan pergi ke memory address register and then dia pergi kat memory. Okay, dia kata 301 ambil instruction. So dia ambil instruction. So dia ambil data. Dia ambil instruction yang ada dalam address 301 lah, which is 5941. Okay, so 5941 ni dia akan masuk ke dalam instruction register. Okay, so dalam instruction register. So bila instruction register dia kata decode. Okay, dia decode. So bila dia decode, okay, dalam arahan ni dia ada opcode. Okay, opcode dia 5. 5 ni actually tambah. Okay, tambah. Okay, tapi dalam exam dia tak adalah cakap minta 5 tu tambah Okay, 5. Okay, so 5 ni dia minta tambah dengan data di dalam 941. So apa yang instruction register, okay, dia pergi bagi tahu dekat MDR. MDR akan bagi melalui MAR. MAR akan pergi ke 941 punya address dan pergi ke 941. Okay, dekat situ ada data. So data dia adalah 002. So 002 ni akan dihantar ke dalam MDR. And then apa dia buat dalam arahan ni, dia kata tambah. 5 ni actually operation tambah. So apa yang dia tambah? Dia akan tambah nilai accumulator yang sedia ada, okay, which is 3. And then 2 yang dia ambil tadi address terbaru 941, dia akan tambah. And bila dia tambah, dia akan simpan dalam accumulator. Okay, override. Dia akan override terus masuk dalam accumulator. Okay, so The next one, you tengok you punya program counter daripada 301 tadi, dia akan jadi 302. So the next instruction 302. So dia pergi ke address 302. So dekat 302 ni, we have a content of another instruction which 2941. So 2941, okay, punya instruction ni akan dimasukkan ke dalam instruction register. Okay, dalam instruction register, so dia akan decode. So dekat sini opcode dan juga dia punya address. So opcode you kata 2 adalah store. Okay, so bila dia kata store, okay, so dia akan store apa? Dia akan store data ke 941. Store tu means you save data into the memory. Okay, so dia store data. So bila dia store data, dia store apa? Dia akan store whatever value in your accumulator masuk ke dalam 941. So data accumulator tadi 5 ni, dia akan masuk ke dalam 941. So this is how the process of the program to be executed. Okay. Alright. So the instruction state diagram, okay. So this is instruction state diagram, So bila dia ambil, alright, the instruction is being fetched, okay. So apa mula-mula mesti program counter lah. Okay, the instruction address. So the instruction address, okay, dia akan ambil address, okay, maksudnya ambil address daripada program counter, okay, masuk ke MAR, okay. So MAR, daripada MAR akan pergi ke address, okay, dia ambil instruction tu, okay, dia ambil instruction tu masuk ke dalam instruction register. So bila dia ambil instruction tu, dia akan decode the operation. So bila dia decode operation, okay, dia kata apa? Okay, dia kata masuk decode instruction tu. Kalau dia perlukan operand calculation, so dia perlukan operand calculation. Kalau dia perlukan operand punya fetch, dia masukkan operand punya fetch, and then they do several operations, and then you have operate the data, okay, and then bila operate the data, so the data will do some calculation, do some additions and so on, and then dia simpan data masuk ke dalam memory, okay, right into the memory, okay. Alright.